Hello everyone, I'm Rashmi. I'm one of your instructors for this course. I also serve as Director for Digital Learning and Library at Arlington Public School alongside with the Leslie Steam team. And I also work for a nonprofit called C Steam Futures. This week, we will explore the concepts of how computer codes, a flowchart, storyboarding, aid in understanding and communicating an algorithm to both humans and computers. In this week's content, we seek to learn about various aspects of computer codes using flow diagrams, or popularly known as flowcharts. These diagrams are useful for planning or documenting all sorts of processes. They're especially useful in computer science for designing programs or algorithms. We will also discover and share resources for teaching about flowcharting and storyboard processes. An algorithm, as you know, is a mathematical method of solving problems, both big and small. Through, though computers run most algorithms constantly, humans can also solve seemingly simple situations and also complex problems using algorithms. Please do review a video description that I've posted by David J. Mallon, who explains how algorithms can be used in everyday life to solve problems. Explaining a process of rules about how to do something to someone or an object precisely is hard work. It's easy for people to misunderstand or miss key steps. Computer programs are a bit like games with rules that need to be followed in a specific order, flow as well as logic. The rules are all written out in a computer program. Not everyone is able to read or write computer programs or code. So, showing what a computer program does by showing the code is not helpful to people who are not familiar with it. This is where a flowchart comes in. A flowchart shows a step by step process using boxes connected by arrows that indicate the direction of the flow. These arrows are called flow lines. Let's look at an example that I posted here. This is one that talks about whether we need to repair a lamp or not. So if a lamp is not working, you have an option of checking whether the lamp is plugged in. If it is, you might look if the bulb is burnt out, and if it is burnt out, then you would replace the bulb. If it is not burnt out, then you will repair the lamp. But there's also another arrow that's going from the lamp plugged in, and that is the no aspect. So if the lamp is not plugged in, then you will plug in the lamp and that will solve the problem for you. So that's your flow of logic in this case. Let's look at this is sometimes how the flow lines or the arrows within a flow chart look like. As I said, they are called flow lines. The flow chart is a great way of visually explaining to people how a computer program works. In a flow chart, actions are represented by standard geometric shapes or which are formally used. So people can quickly understand what is happening at each stage. Most programming flow charts use four main shapes. First one is an elongated circle. This indicates the beginning or an end of a process. It is called a terminal. Next is a rectangular shape. It indicates actions. Third, there is a diamond, which indicates where a decision needs to be made. In programming, they usually represent conditional statements from the program code. Lastly, there is a parallelogram, which is used to indicate inputs and outputs. For this part of the program, users are required to input some information or the computer displays some information on the screen. You can use other shapes, but remember the purpose of flowchart is communication, so it's best to keep it simple and keep to the predetermined shape or predefined shapes as mentioned in a handout that we have included. So these are all the symbols and the meanings that we have included in the readings that you can use. It's always, again, preferable to stay within the confinements of these predetermined shapes so that we can communicate effectively. Flowcharts are also especially useful to bring different programmers together, especially if they're using different programming languages. This actually allows them to focus and understand the process of solving the problem that is in front of them. Um, in there is an assignment that we have included in the unit which will allow you to look through recipes that you have created or different types of problems that you engage with on a daily basis, and then turn them into flowcharts. Now, here is an example that I have put in, which is about um, encouraging you and I to cook more. I personally love cooking, but this is an example of how one would want to look into the logic of how to possibly cook more. Here are a few more. We've included the black bean brownies example in your reading, but there's also this a little bit of a complicated flow chart about the smoothie. And then here are a few more, which can be an interesting read, which I'll also post in our readings for your pleasure. Flowcharts can be complicated depending on the logic involved. As you can see, we have a yellow Thai curry in here, and the flowchart looks a little bit different, and there is programming involved at different stages. So in this unit, we are not looking for an exact definition, but rather looking for ways in which computer science, computer codes, flow charting connects with the real world, and helps us solve problems as well as enrich our computer science concept teaching and learning. Through the various readings, articles, hands on assignments, and interactive physical computing exercise, which is essentially you would be engaging with an image rotation animation example, which looks like this. This is going to be the handout that you'll be engaging it, where you will be building a microbit image rotation animation block. You will be using different types of blocks, which look like this. So you would be using a conditional block called while, which repeats code with a while with a condition when the condition is true. You'd be doing a variable declaration on button pressed button, show LEDs, and a pause button. Your ultimate activity will look something like this, where you will make sure you save your program with your name and you can add comments to your program as indicated in the assignment. And this is just an example of how it could work. You can of course vary the pattern depending on your preferences, but you can see that we have created a variable rotating, and then there are setting a variable and changing the variable aspects that are engaged in the program, along with the while loop, which will be in your loops section, and you can drag it out and you can pull it on the screen and use it. So that's your quick assignment. I also um, wanted to give you a quick preview of my apologies. Um, I also wanted to give you a quick preview of the Discover Reflect question, where you will be understanding how computer codes, flowcharting, and storyboarding connects with the real world, and adding some of your own examples that you find through your research into the teaching and learning guide. So lastly, the curriculum postings for this week will provide you with the links and course materials required for the assignments. And there is also an assignment for the discussion board. We look forward to collaborating with you. Thank you so much and have a wonderful day.